kidney. In kidney we also have cortex and medulla. Medulla has pyramids, renal pyramids. They are lobes of pyramids, or lobes of kidney, renal pyramids. And space between these pyramids, that is columna renalis, that is part of medulla of kidney, in space between pyramids, columna renalis. Apex of pyramid opens into lesser calyces, calyces renalis minoris, and lesser calyces join together and forms greater calyces, and greater calyces join together and forms pelvis renalis. And from pelvis renalis start ureter. Ureter start from pelvis renalis. And if we have lesser calyces, greater calyces, and pelvis renalis, we speak about a major type of excretory tree of kidney. Sometimes lesser calyces directly opens into pelvis renalis, and greater calyces are absent. In this case, we speak about embryonic type of excretory tree. And sometimes lesser and greater calyces we can see, and pelvis renalis is absent. Greater calyces continues into ureter. In this case, we speak about fetal type of excretory tree. Embryonic, that is absence of greater calyces. Fetal type, absence of pelvis renalis. And major type, all three components are present. Now, vessels, arteries of kidney. It is aorta, abdominal aorta. From abdominal aorta we have renal artery, arteria renalis. And renal artery usually subdivides into three: arteria polaris superior, arteria centralis, and arteria polaris inferior. These three main arteries subdivides into arteria interlobaris in kidney, and these interlobar arteries on the border between cortex and medulla continues into arteria arcuata, and arteria arcuata makes anastomosis, one from with another, makes anastomosis. That they are arteria arcuata. Arteria arcuata on the border between cortex and medulla of kidney. And from arteria arcuata we have arteria interlobularis. They goes into cortex of kidney, and arteria interlobularis gives vas afferens or arteriola afferens. It goes to glomerulus, and from glomerulus start arteriola efferens. That is arteries of the kidney, and this diagram you need to draw next time. Number 1, aorta abdominalis. Number 2, renal artery. Number 3, arteria polaris superior. 4, central artery. 5, arteria polaris inferior. 6, arteria interlobaris. 7, arteria arcuata. 8, arteria interlobularis. 9, arteriola afferens. 10, that is glomerulus, and 11, arteriola efferens. They are arteries of the kidney. And now another diagram, that is structure of nephron. It is the same, arteria interlobularis. It is number H at my first diagram. Arteria interlobularis gives arteriola afferens or vas afferens. It is number 2. It makes glomerulus, network of capillaries, number 3, and from glomerulus start arteriola efferens or vas efferens, number 4. And glomerulus surround capsule of nephron, Bowman's capsule. And this Bowman's capsule continues into proximal convoluted tubule. Proximal tubule continues into straight tubules, and stretch tubules has descending limb and ascending limb, and here it is Henle's loop. Then distal convoluted tubule continues into junctional part, and junctional part insert into collecting tubules. But collecting tubules, it is not part of nephron. Last part of nephron, that is junctional part. Number 5, capsule of nephron or Bowman's capsule. 6, proximal convoluted tubule. 7, that is descending lip of Henle's loop. Number 8, loop of Henle or ansa nephroni in Latin. Number 9, ascending limb. 10, distal convoluted tube, and 11th, that is junctional part. Number 12, collecting tubules, it is not part of nephron, that is excretory tree. And this afferent